So this talk is about reactive programming, so it's probably worthwhile to take a minute and kind of define what I mean when I say reactive programming. So what I primarily mean is programming with asynchronous data streams. In the RxJava world, that means observables. In the flow world, that means flows. To make things more complex, there's flowables in RxJava, so I can't call flows in Kotlin flowables, so I'm going to call them flowsies. That's a word I just made up. I'm not going to call it that. So reactive programming with asynchronous data streams, and probably more important is propagating change and then reacting to that change. So fundamentally it means I push out some update and some other code reacts to that update. That's all well and good, but it's mostly just words that mean nothing without any code. So here's a quick sort of example of what I mean. So here we have a ViewModel. For those who aren't Android developers, a ViewModel is just like a little thing that lives next to your view that powers some of the logic. And it's got one function on it to fetch some network stuffs. This is an ironic function because it's not fetching anything from the network. I'm not even hiding that, it's just a list of strings. But pretend it fetches some stuff from the network. So that's our ViewModel. Then maybe we have some view. It creates that ViewModel. It's an init block. It goes to the ViewModel, fetches some network stuffs, and then it do stuff with my good stuffs with the network stuffs. So it takes some action on the network stuffs. I expected somebody to laugh at that, but nobody did. So that's good. That's good. Basically, we pull stuff from the network, and then we do something with that stuff. Additionally, we have some function that gets called when some button is clicked. And again, we go to the ViewModel, we fetch some network stuff, and we do stuff with it. So this is a non-reactive example. Another fundamental part of reactive programming is sort of this push-don't-pull mentality. And you'll see here from this code that we're really pulling from the ViewModel. So whenever this view needs something of interest from the ViewModel, it's pulling it at the point that it needs it. So now we can look at a slightly more reactive example. So we're back in our reactive ViewModel, and now instead of just exposing the fetch network stuffs method, we instead expose a stream of network stuffs. Our network stuffs is just a list of strings. In our initialization block, we're fetching network stuff and then piping it through that stream. If anyone's listening to that stream, great. If they're not, this ViewModel does not care. It's just whoever is observing it can react to those changes. We also expose another function which refetches stuff and then pipes it through that same stream. So this is kind of different because instead of a view going to this ViewModel and saying, hey, I want network stuff, give it to me right now, instead it's saying, something happened, maybe you should do something, and then it's going to react to it the way we react to anything else. And if we look at that view, we can see we're doing just that. So we create our ViewModel, we get the stream of stuff from the ViewModel, and then we call some function whenever a new item is emitted through that stream. The nice thing about reactive programming is it means we don't need to duplicate a lot of this logic, and we know that a lot of our state is up to date because we're representing it as a stream of objects instead of like a single snapshot in time. That's some of the benefits that you get. So this is a very convoluted example, but that's a tiny little reactive example. So now the question is sort of, why does that matter? Why do you care about reactive programming? What benefits does it actually have? There's a little bit more code, so is it worth it? So there's a few main benefits of reactive programming. The first one is that it keeps your data up to date. So one of the examples that really made it click for me when I was first trying to learn RxJava and actually using RxJava as a streaming library instead of just a library to fetch some network stuff was an example where you have like a user ID or something. So imagine you're in some Android app, a user can log in and that'll update the user ID. The user can log out, that'll update the user ID. And then you have some class like an analytics manager or something along those lines that needs to know about that user ID. So if you represent the user ID as sort of just a static number, then you need to remember everywhere to update that analytics manager. And you won't remember to do that because none of us think about the analytics manager. We just log out and that's it. But if you're instead representing that user ID as sort of a stream of values, then it's built into the type system that this thing can change and that you need to react to that change. So it helps kind of keep your data up to date. It also allows for more declarative code. So you saw in our previous example, which I can actually pipe back to, that for this view, we kind of set up the logic in the initialization function. And when you go all in on reactive development, you end up in a world where you can effectively model your program in one constructor or initializer block. Maybe you don't want it in the initializer block because you don't want to execute logic when a class is created, but the moral of the story is you're sort of tying everything together in an upfront way such that you can see the state of your program at the beginning of your program rather than as a bunch of sort of random states that come together throughout the rest of the program. One of the points that I like to say about reactive programming, which is definitely a me opinion, is that it sort of represents a more honest modeling of our applications. This is kind of, again, this is just my opinion, but so we, in our Android applications, have a lot of things that we kind of like to pretend are synchronous events that aren't synchronous events. So we have all these sources of rabid asynchronousness in our apps, like a user clicking a button, or a user navigating somewhere, or some action happening, something coming from the network, some WebSocket being pushed out. All of these asynchronous streams, or maybe like a lifecycle event within your Android application, all of this asynchronous stuff is stuff that we try to kind of smush into an imperative step-by-step world, and we just don't live in that world. So when you kind of embrace reactive programming and you embrace the idea that data is, most of the data we're interacting with is streams of data, then it kind of represents a more honest modeling of the application. And then the last point here is that it kind of unifies the asynchronous and the synchronous. And this is a very interesting point when it comes to coroutines. But reactive programming sort of, especially RxJava, helps to unify the worlds of the asynchronous and the synchronous by making everything asynchronous. It's probably worthwhile to spend a little minute there, because usually as programmers, when we think about solving some of the complexity of asynchronous programming, we don't think of doing that by making everything asynchronous. Usually we'd rather make everything synchronous. And we'll see that coroutines kind of let you do that a little bit. But when you employ this model of reactive programming, especially with RxJava, you go more in the everything is asynchronous world, and you stop ending up in these scenarios where you sort of have synchronous code that's jutting up against asynchronous code that you're trying to mash together. Instead, if everything's in this asynchronous world, then it all flows a little bit more naturally. So those are some of the benefits of reactive programming. And that leads to the next question of what do coroutines mean for reactive programming in Android? So this is a little bit shameful, but not the water boss, that's not shameful. It's a little bit shameful, but when coroutines first started coming out for Android, I was not convinced and a little worried about them. I was kind of concerned that if everyone started moving to coroutines, which, like I previously mentioned, kind of tries to unify the synchronous and the asynchronous world by making everything synchronous, that everyone would start to drop this sort of reactive programming paradigm shift that had been happening in Android development. And that made me sort of rigid about coroutines and feel like, oh no, we're moving in the wrong direction, like the technology is fascinating, and it's very well done, but I'm scared that we're going to end up back in this world of imperative programming that I think doesn't work quite as well for UI developments. And that led to a very common title of Medium posts and conference talks. I think there's one today that I'm interested in seeing, which is this sort of coroutines versus RxJava, and what that means. And that title too, it makes sense within the Android context, because like I said earlier, everyone in the Android world has sort of been using coroutines to do crazy simple things like just make a network call, or to just put something in the database. But in reality, these really aren't analogous things. Coroutines, at least most of the async await sort of stuff that I think most people mean when they say coroutines, is really about executing these sort of singular asynchronous actions. So again, pulling something from a network, inserting something into the database, little things like that that represent a single action, whereas RxJava is this library entirely built around streaming values and observing asynchronous sequences of events. And those just aren't the same thing. Like the title coroutines versus thread, that makes a ton of sense because it's kind of some direct competition. But this title is a little scary to me. Like I said, it makes some sense in the Android world since we're just doing these little asynchronous actions, but I'm not a huge fan of this comparison. love this comparison. This makes perfect sense to me. This is the part where we introduce Flow. So Flow is an asynchronous cold streams library produced by JetBrains, and this goes in direct competition with RxJava. They're really two libraries built to do the same thing. So while I could see a world where you used normal coroutines in addition to RxJava, sort of Flow and RxJava are actually competing over the same thing. So this is the question that I think is a bit more interesting, at least when we're talking about sort of streams of events. So let's do a quick introduction to Flow. Like I said earlier, Flow is cold streams implemented with coroutines. I don't want to spend too much time on this, but there's cold streams in the world, there's hot streams in the world. Hot streams produce even if no one's subscribing to them, even if no one's listening, whereas cold streams typically don't start executing until somebody subscribes to them and starts collecting them. Flow also respects structured concurrency, so all the exception handling we've become used to and doing jobs and all that sort of stuff, that's very different from RxJava, and it's kind of more fundamental into the world of Kotlin. It's heavily inspired by existing reactive frameworks. We'll see that in a minute. And it's got a fairly simple design and API. That's kind of surprising because, like I said, I love RxJava, but it is definitely not simple. It's definitely not a small API. It's definitely not a small lift. And Flow actually takes steps to try to make it a little more clear and obvious what's going on. So let's do some quick comparisons. I meant to have these like fancy fade between the two, and then I didn't do that. So here we go. Anyways, so when we're constructing an observable or we're constructing a flow, which I believe I'd call a flowzy, is that it? In RxJava, you can do observable.just, give it something, and that'll create a stream of that item. So for the first example, we're going to create an observable with one item, the integer 1. Very similar thing in Flow. You can use the flow of function. You can see we're in Kotlin land, so it's a top-level function, and you can pass in 1 into it and create a flow of that integer. So we're already starting to see that while they have an extraordinarily similar API, Flow is built more Kotlin-oriented, which makes sense since it's built from people who made Kotlin. You can see we can do similar things with sort of creating an observable from a list of items. So in this top example, we're creating an observable from a list of integers from 1 to 10. And in the bottom example, we're doing the same thing with a flow. Again, Flow has nice extension functions on top of lists so that you can do that a little bit more naturally. I don't know how often you'll actually be doing this sort of thing, but still, kind of cool. A lot of times you'll end up in a world where you're trying to kind of take what has been presented as a callback, and you're trying to stuff it into an observable or into a flow. With RxJava, you use the create function with Flow. They have a nice DSL. It's really starting to come in. Yeah, Flow is Kotlin first. Looks a little nicer in Kotlin. And then when you're observing things, so in RxJava land, you have some observable, you call subscribe on it, you print it out. You get a disposable back, and you can use that disposable to sort of end the subscription to that observable. And in Flow land, instead of subscribe, you have this collect call. These actually aren't analogous, and this code down here wouldn't really compile. So if you look at, so the collect function is has a little bit more going on than the subscribe function. And whenever I run into an issue where I don't understand something, my first impulse is to look at the types around it. So let's take a look at the types around collect. Oh man, I love this. I bet no one can read this. It's got all these fun sort of Kotlin keywords. It's such a beautiful Kotlin-y bit of goodness, and we don't care about any of it. The only thing we really care about is this suspend keyword here. So when you call collect on a flow, that is a suspending call. And whenever you're making a call to a suspending function, you have to make sure to do it in a coroutine context. So that is a huge difference between RxJava and Flow. It's something that we'll see in a few future examples, and if we have time in some of the Reactive to do app. So when you're calling collect, when you're actually making that final execution to kick off the cold stream and to start listening to the values that come through, you have to be in a coroutine context. Another thing that's very interesting about this that sort of caught me off guard is that that means that collect is blocking within that coroutine context. So if you have some flow that's emitting an infinite stream of values, and you call print line right below that, that print line isn't going to be executed until that flow finishes flowing. That's a massive change between RxJava, which is sort of built to be fundamentally asynchronous. But it actually has some really interesting benefits the way Flow does it. We'll see those in a little bit. So continuing our comparison, applying operators looks literally exactly the same, except that Android Studio chose to highlight, filter, and map because they're extension functions. Yep, not much to say there. Things look literally exactly the same. Changing threads is really interesting. So when we're using RxJava, a lot of times we'll use subscribe on to sort of take the chain that's going above it and then pop it off to a different thread or a different scheduler at least. So maybe we're making some network call. We don't want to crash in Android land, so we pop off to the IO scheduler. I found that you actually need to do it a little bit less in Flow because you're already in this coroutine context that's handling some of that asynchronicity for you. But if you do, Flow has the flow on operator, which will change the coroutine context that you're working in. Pretty similar, right? I like that I have these like little slides where I say the thing, and then you can all confirm that I've said the thing up there. Really important, fundamental to the topic. Well, there's other really interesting differences, and this kind of expands upon the suspending nature of collect that I talked about before. So for those who aren't familiar, fold is a really common functional function that takes up some iterable and sort of combines it up into one thing. So you use some accumulator, you walk down a list, and you get back one object. RxJava doesn't call it fold, it calls it reduce. I learned while I was looking at the source code of reduce that languages like Groovy and Ruby call fold inject, which is wild to me. Anyways, that doesn't matter at all for this context. So when we're folding a stream, what we get back from reduce in RxJava is a single of some integer. Basically a single of the thing as you're walking down the observable that combines it all up. I kind of expected Flow to work the same way. So we're calling fold, we're walking down this flow, what do we get back? But again, this code here wouldn't compile as it is, and as always, the thing I like to do is take a look at the types. Or quote Android Studio as it yells at me that the suspending function fold should only be called from a coroutine or another suspend function. Again, this is good, it's important. So let's take a look at the RxJava types. All this stuff here, we don't care about most of it. The only thing we really care about is that reduce returns a single in RxJava. For those who aren't familiar with it, a single in RxJava is just a stream that has only one value, but it's sort of still in this asynchronous construct of this single router. What's a single in Flow? Oh man, I love this slide. Again, like, this is such a great method header. It has all these wonderful keywords that are so confusing. Again, we don't care about any of them except these two. So when you call fold on a flow, it's again a suspending call. And it returns just whatever the type that the accumulator you pass in is. So we can ask the same question, sort of, what is a single in Flow? Well, a single in Flow is just a value. There's no extra asynchronous wrapper around it, other than the fact that it's a suspending call. And that was kind of a bit of a mind-exploding, if I was good at memes, I would have done exploding mind GIF sort of thing. But there's this big list of terminal operators in Flow that sort of take you out of a flow and just give you back the value, which is really interesting and a really big paradigm shift from RxJava. We're kind of always staying in this asynchronous construct. So there's a bunch of these terminal operators, so reduce and fold. If you're trying to get the first item in a flow, that'll just give you an item. The return type of that will just be T, whatever the T is in your flow. If you're bundling up a flow into a list, again, it'll just give you back a list. There's no sort of extra prompt and ceremony to getting it. You just get it back. So now that we've kind of walked through some of the superficial differences between RxJava and Flow, I can introduce my amazing Reactive To-Do app. Make sure you don't take any pictures or videos because this is intellectual property that nobody should get. Boom! Wait for applause. I even have a GIF here. So this is a little to-do app. It shows a list of to-dos. You can then click a plus button, and you can add it to do. It doesn't even copy that. And you can see it in this list. So click plus, type in some stuff, click check mark, pop back, you'll see it in the list. Pretty simple app. You can also delete stuff, swipe it to delete it. For some reason, I felt the need to prove to everybody that it actually deletes it here, like out of the database. And it does. I don't know why I didn't think y'all would trust me for that. So that's the Reactive to do app. And probably the more interesting thing about it, the more interesting thing about that app is that it's built with a reactive paradigm. So we're going to take a look at the code in a little bit, but very quickly at a high level, we basically pump stuff into a room database, and we observe that room database for lists of to-dos, and then we update according to them. So let's take a look at the code. Here we have the main to-do view. This is a ton of code that nobody's going to actually care about. The only thing that's really interesting here is that in this sort of main activity that's showing the list of to-dos, we're getting our stuff by taking this view model that we'll look at next and observing a list of items. That's the whole way that this view is updated. All it does, its whole UI interaction, is observing the view model and populating a list. There's other actual Android stuff that doesn't matter at all for it, but that's the interesting part there. Next up, we have this main view model. This is wonderful because there's no chance in the world anyone can read this code. Promise I zoom in and all that sort of stuff. But one goal I have as we're going through this talk is for this file to become readable when presented. So there's a bunch of different stuff going on here, so we're going to take some time to kind of walk through it. It's also kind of the powerhouse of the app, powerhouse for this huge app. But the thing that really drives most of the logic. So to start with, we can take a look at some of the variables that are declared up top. Two important things going on here. One, we have a subject. Subjects represent hot streams. I mentioned hot versus cold before. It's just a behavior subject. It's not really important to know what the difference is there. And then since you can kind of push things into a subject, it's a nice way to sort of bridge the reactive and non-reactive worlds. And I like them for sort of organizing my code that I'm going to present to the UI. You don't want to expose it to the rest of the world because it means other classes could inject things into your subject. So we have this observable on the bottom that just hides the subject and just makes it so nobody can mutate the subject, basically. Then we have some disposables to clean up after ourselves. Next up, we have the init block. One thing that's kind of interesting about a lot of reactive apps is that you actually end up having all of these Rx constructs in the init block, which is was very non-intuitive for me at least. I've really come around to it, but I've always found that interesting. This chunk of code right here is the thing that, this is probably 80% of the app, is this 8 lines here. So we're going to take some time and kind of go through it step by step. Like most RxJava change, it's kind of impossible to understand until you take the time and really walk through each piece. Again, I love RxJava, but that's definitely one of the trade-offs. So the first thing we can do is take a look at this fetch to-dos function. So we're passing in a network service into this view model, and then we just fetch a list of to-dos from it. Fetch to-dos returns a single, that thing we talked about earlier, which is just an asynchronous wrapper around a single object. We take that single, and then we use the flat map function to take all the to-dos we got from the network and then stuff them into the database. We need to use flat map because we're going from one single into a different single. So insert tasks returns another single. It's just like a list of IDs that we actually don't care about. But we need to use some of these slightly more complicated functional paradigms, i.e. flat map, to do this. When really all we want to do is fetch some stuff from the network, wait till that's done, and then put it into the database. So then, once we've finished inserting the stuff from the network into the database, we want to use flat map again to start observing things from the database. Now, technically speaking, we don't actually have to wait to finish the one before, but I kind of want to prove this point of some of the things you have to do in RxJava. We need to use flat map observable here because we're going from a single to an observable, and since those are two different sort of asynchronous wrappers, you need some extra hand-holding to get the two to mesh. And then there's some Rx boilerplate here. We don't want to do network stuff and database stuff on the main thread, so we're popping off to a background thread. And then we're piping all the stuff through to that subject. And we want to clean up after ourselves, so we're adding to a list of disposables. Okay, great. So next up, we have this to-do updated function. So this is exposed to the rest of the world. I don't know if everyone saw the awesome talk about putting the fun in functional programming yesterday, but one of the other interesting things about this sort of unidirectional reactive flow is that it breaks a lot of those purely functional paradigms of having pure functions. Like this is one unpure function, and I still love it. I love you to-do update. So basically all we're doing here is we're reaching into our database, we'll take a look at that next, and inserting a task. Again, there's a bunch of extra sort of RxCruft for subscribing off the main thread, adding it to our list of disposables, and sort of kicking the stuff off. And we have the to-do deleted function. That's almost exactly the same as the to-do updated function, except we're calling delete. And finally, we have this onCleared block. We're good Rx citizens, and when this ViewModel goes away, we want to make sure to clean up after ourselves. So we're disposing all of the stuff that we're getting from RxJava, all those sort of jobs. Fun in a bun. So next up, we have our database. So for those who aren't familiar with Room, it's a database library. Again, it doesn't really matter. I probably could have omitted all of the annotations here, but this is the interface into our database. Basically, we can insert something into the database that produces a single, so we're in this asynchronous construct. I'm going to keep saying that so it kind of drives in. We can insert a list of things into the database. Again, returns a single. The singles we're getting back here are just singles of IDs that are updated, like row IDs that were updated by that action. Then we have the one that's actually important here, which is the thing that lets us observe stuff from the database. I love Room because it enables this reactive paradigm. It's really hard to do nice, good reactive programming without good libraries like Room that'll actually notify you when things change. So that's what's happening here. This is the most important function in the app. It's a good one. And we have the delete function, which just deletes something from the database. This one returns a completable. For those, again, who aren't RxJava familiar, a completable is basically just a runnable that's wrapped in an asynchronous construct. Basically, you can subscribe to it, it'll execute some function, and you'll be notified if it succeeds or fails. So probably the most important stuff for this is actually to look at the return types. I kind of outlined them already, but we're staying within this Rx construct for the whole thing. And we have this network service. Sneak peek is fake. So we just have an interface here that lets us fetch a list of to-dos. It returns a single. You're seeing a very common pattern here, lots of singles and completables and whatnot. And that's that. Last but not least, we have that view that you get to when you hit the plus button, the thing that actually inserts a task into or a to-do into the database. The only thing that actually matters for this little bit is this chunk of code right here. Did I blow that up? Nope, I didn't. So we create a to-do, and then we insert it into the database. We don't even have a ViewModel here because either I got lazy or it wasn't important enough to need a ViewModel. I'll let you decide which one happened there. I got lazy. So that's really all of the important code in the app. It's like 4 or 5 classes. Here's a quick little small diagram of sort of the architecture that's going on here. So we get a to-do, we have our to-do list view, that updates or deletes to-dos from the database. We have that add to-do view, that adds stuff into the database, and all the while, as anything changes, the database is emitting lists of to-dos back to the to-do list view for it to observe. And that's basically it. That's the whole app. So let's get flowy. So we're going to convert this app to flow. That's what let's get. So the first thing I wanted to do as I started to, and this was really my, this app was me starting to learn about flow. So I don't want to present myself as an expert. So the first thing, trust me. So the first thing I wanted to do when I was going from this RxJava world to this flow world was to find some way to bridge the gap. It's not actually crucial for this tiny app, but if I'm in any meaningfully sized application and I make the decision that, hey, I really want to move to flow, I want to execute this action to change the reactive library I'm using, there has to be some way to sort of bridge the gap. Luckily, JetBrains, who is absolutely crushing it, gave us just such a library. So they have a Kotlin X Coroutines reactive library. It's extremely complicated, very wide API surface. This is the whole thing. It has two things to really take a publisher, which is a reactive type that RxJava supports, and turn it into a flow, or to take a flow and turn it into a publisher. The critical thing here is it means that we can go from an Rx construct to a flow construct, and we can go from a flow, paradigm construct back into an Rx construct. So we can kind of go back and forth. The only one we actually care about is the top one. We're going to convert things to flows. We're not going to take any flows and convert them into observables. So we can start off by focusing on the main observable that we have in the app, which is this top one to fetch a list of to-dos from the network, insert them into the database, and then start observing the database. So this function is awesome, very easy, so it's just called asFlow. This actually doesn't work because an observable isn't actually a publisher in RxJava. A flowable is a publisher. So we got to call two flowable there. That's fun. And now there's some other issues. We can't subscribe to a flow. We need to call collect. Nice, nice, nice. We're just piping things through to our subject again. But there's actually another issue, which is that we're not in a suspending context. So we need to be in this coroutine context since the collect is a suspending function. So we need to add that in there too. Luckily, there's a bunch of really nice ViewModel integrations with coroutines, so we have our ViewModel scope that we just launch. Easy peasy. Next up, we want to migrate deletion. So I figured deleting something is a small enough ask that we can just kind of take that on really quickly. That's this function down here. It returns a completable. So we have to ask ourselves, like, what is a completable in coroutines? And I, again, struggled with this for a minute, but it turns out a completable in coroutines is just a void function. It's something that returns unit. We already have that suspend context that tells us that this is within the asynchronous world, so we don't need that extra wrapper around it. So we can just make delete to do a suspending function, get rid of the completable, make it unit. We don't actually need to say that it's unit. So delete to do just got a fair bit simpler since we're just going to do it now. And we can look at the to-do deleted code. So we have all this RxCruft. Most of that goes away. Now we again just take our ViewModel scope and launch it, and we delete the to-do. We can make that a little bit simpler, so we just cleaned up a lot of code by switching there. Like a quick second here, so we removed this Rx construct, but it's worthwhile to note that we removed a completable and went to a normal coroutine suspending function. And completables and singles are kind of in this Rx world where they can make some sense at some times when you're using these reactive constructs, but for the most part, when I use, at least when I use them in Android, I just mean, I'm making a network call, hey, I'm pushing something into the database. So they're not even fundamentally reactive flows. They're just things to represent some asynchronous action. So that got a lot easier. Next up, we can migrate insertion. So very similar story here. We're going to make this a suspending function. Instead of being a single, we're just going to have it return long. Pound this in there. So the suspend keyword is what lets us know we're in this asynchronous construct. So we don't need that extra sort of type wrapper around single because we already have that in the form of a suspending function. There's a couple spots that are actually inserting stuff into the database. The first one is in that add to do page. So we're going to blow this stuff up. Some RxE there. Most of it goes away. We just take our lifecycle scope, another nice thing, activities that goes in context, and we push it into the database. Easy peasy. And whenever we update a to-do, we're also just using the insert task method. So whenever you toggle a to-do on or off, this just goes through the same insertion flow. So that becomes very simple, just like the to-do deleted flow. And next up, we need to migrate our network service. So what's going to go? Oh yeah, look, I had a nice. That breaks up this 50 slides of code really well. I'll just sit on it for a while. So within our network service, this becomes really simple too. Instead of having something that returns a single of a list of to-dos, it's just a suspending function, returns a list of to-dos, ready to go. So we're still migrating that network service, and the spot where we're actually using it is in that init block. So we have this sort of Rx construct where we get a list of things, and then we use flatmap to ensure that we finished getting that previous list, and we can react to it and handle it and do something else with it. So it turns out, I was actually a little nervous about this because I wasn't sure how it would work. Like, since we're using this somewhat complex flat map scheme here, how's it going to work? Turns out it's really easy. Basically, we just get rid of most of it. We make the call to get the network items. Remember, we're already in this coroutine context, so we can just make that call. We don't need to do flat map to wait until it's finished because it's a suspending function. It's just finished. So then we insert the tasks into the database, and then we keep on going with the rest of the Rx flow. So migrating this actually ended up being super duper simple. Step 3.5 is migrating more insertions. Since we have an insert task, we also have a way to insert a bunch of tasks. I think everyone kind of knows what's going to happen here. It's a suspending function that returns a list of longs instead of a single of type list long. And we've got to use that in this init block again. Again, we need to figure out how to do this thing, wait for it, and then transition to something else. We're in a coroutine context, so let's just do it. We just insert the tasks, and then the next step is to start that to do observable and get that actual reactive stream going. But since we're in this coroutine context, things that used to be thing1.flatMap into thing2.flatMap into thing3 are just statements one after the other. I forgot what step we were on when I was writing the slides, and I didn't bother to look, so step 5, I guess. Migrating the one thing that's actually important for this talk, which is the to-do observable. So this is the part where we're actually using some reactive paradigms. For everything we've done so far, we've been highlighting the fact that we're using RxJava for things that aren't actually facilitating reactive development, or at least things that aren't facilitating reactive streams. This is something that's actually a reactive stream. So the first thing we're going to do is we're going to swap it from an observable to a flow. That makes sense. The talk is about flows, theoretically. And that's it. So that's interesting because for all of our other functions, we were popping the suspend keyword on top of there. But you only need to have, the only part about a flow that's suspending is those terminal operators. So collecting something or calling first or single or whatever. So that's it. We don't need the suspend keyword yet. Also, we want to rename it to to-do flow since it was to-do observable. And now we can pop back into the main ViewModel, look at this primary init block, and kind of reassess what's going on here. So obviously this changes. It's not to do observable anymore. It's to do flow. That's easy. And then we've got some more stuff. So we've got our subscribe on function to change our thread. And we've got some extra cruft to get rid of, or to go to a flowable so that we can then convert this thing to a flow. So we know the flowable stuff and as flow is going to go away because this is now already a flow. But it turns out the subscribe on block can also go away. And then we're just left with this extremely simple, clean, tiny little collect call. And actually this can be further optimized. So step 6, we're not subscribing to anything anymore. So we're not getting any disposables. Remember, disposables are the way that we clean up after ourselves in RxJava. So we can get rid of the disposables now. The coroutine context will automatically cancel our jobs, not cleared, so we just bail on that. And this is actually, this is getting almost readable, especially if I increase the font, which I just did. Look at that, we can read our to-do view model now. No, you still can't read it, Anton? Wonderful, thanks. Sweet, so we've switched this thing that used to be a to-do observable into a to-do flow, and now we need to get rid of this last bit of Rx that we have in the app, which is the thing that we're exposing to the view. So right now, we have the subject that we're piping stuff through, and then we're exposing an observable for the view to subscribe to. So that led me to the next question, which is, what's a subject in coroutines? In this scenario, you don't really need a subject. You could just expose the flow that we're subscribing to, but I really like subjects to sort of massage my data and expose the streams that I actually want other people to consume. And it can make stuff a lot easier. So what's a subject in coroutines? Turns out it's something that's been there the whole time. Hot streams have been in the library since the beginning, and it's a channel. So we're going to take our behavior subject and we're going to change it to a conflated broadcast channel. I love it because there's no name that's more frightening to me than conflated broadcast channel. It also makes you think you're doing something wrong immediately as you start using it. inflated feels wrong to me. But anyways, this just mimics the functionality of a behavior subject where whoever subscribes to this channel will receive whatever the last emitted value is, and that's kind of a nice drop-in replacement. So we used hide before on our subject to sort of stop other people from inserting things into our hot stream. And now we can just use the asFlow function to turn the channel into a flow so nobody else can insert new stuff into this other than us. Also, we can clean this up a tiny bit by using a method reference. Is that readable now? All right, well, thanks. There's just no losing you up. All right, next. So now we need to consume this flow. So the part of the code that we actually care about is right here. So we're just doing all the normal stuff. We're observing on the Android main thread to make sure that any thread switching that had happened is undone so we can update UI elements. And this is a familiar song and dance now. We just swap this out to collect. We don't need to observe on the main thread because we're in the lifecycle scope, which already is in that context. So good to go there. And actually, this could also be cleaned up with fun method references. A little bonus here is that we get to get rid of onDestroy here. Again, we don't need to sort of, some of the constructs that the Google team has built into activities and ViewModels to support Kotlin and Coroutines make it so they kind of clean up for us, which is really nice. I hate cleaning up that. And that leaves us there. Step 9 is to remove RxJava dependencies. So we've officially removed RxJava from our app. We still have that reactive flow. We haven't switched from a push-based context to a pull-based context. We're still observing the database and getting all the stuff we need out of it, but we've just gotten rid of a ton of code. So let's go through some key takeaways. So first things first, this is our new ViewModel. I guess Anton still can't read it, but I can read it now. This is our old one. I'd call that a pretty big win. We got rid of so much just Rx boilerplate. And the main place where we got rid of it was in using, I don't want to say misusing RxJava, but using RxJava to do these really simple jobs that coroutines just do better. And then we used Flow for the stuff that actually matters, which is streaming things. Few other takeaways I had from that process. Like I talked about before, big reduction in lines of code. Also, like I was saying before, sort of these pure async actions just feel way more natural. I didn't realize how complex it was to sort of go from a single to a completable to an observable. Sort of you have these like flat map chains, and we weren't using flat map in the way you typically use flat map for, if you're like combining lists or really combining streams. We're just using it to say, hey, do this thing, wait for it to be done, then do this next thing, wait for that to be done, and then continue. And that's just, it feels like such a breath of fresh air to just do that imperatively rather than being forced into this somewhat unnatural construct. Again, all while without sacrificing the reactive nature and the streams where they actually matter. That was a huge takeaway for me. There's some extra code at the end that I was going to show if we have time, but this last point feeds into that. It's a lot easier to reason about terminating operators. So anyone who has worked extensively with RxJava and has done any complex flows know that whenever you call first or last or to list, there's a lot of extra ceremony to go through that to actually get the thing that you want. And the whole time you need to be returning something within this Rx construct. Whereas with Flow, you can just call first and you get back an item. You just call to list and you get back a list of stuff. And you can just return that stuff since you're in a suspending context. And that's the thing that implies the asynchronous construct around your code. I added a meme here. I made this one myself. It says, I call this piece bug-free code because there's no painting on it. So, and any code isn't bug-free code. 10 seconds of laughter. Thanks for all that. Wonderful. Thank you for the clap. Do we how much? I have 45 minutes on my clock. Do we have any time? A few more minutes? Okay. If we have a few more minutes, I have one chunk of code that I'd love to show. I'm going to show that chunk of code real quick, so pause questions for 1 second. Bonus round. Writing real software for nerds, Alex Sullivan. Using a real API, just returning a list of nonsense. Bonus step, migrate fake. Read over here. Migrate fake network service because you're too lazy to real network service, even though at the end of the day it would probably be less work. Again, a lot of laughs. So the point where we're going through and sort of refactoring the network service, this is one of those spots where you have weird Rx code that's like forcing a bunch of paradigms. So if you look at this chunk of code here, you can see I was in this interesting spot where I was mimicking a network, and we were fetching stuff from the network, inserting it into the database, and then allowing people to update their app and update the database. But it meant that every time you'd restart the app, we'd refetch stuff from the network and overwrite anything that had actually been in the app. It doesn't actually matter for a presentation app since nobody would have actually used it, but perfectionists wouldn't allow that to happen. So what I ended up doing was the greatest two-way sync that's ever happened, which is if there's anything in the database I didn't save, this pre-canned list of to-dos, if there was something in the database I did save. So I did that with a bunch of RxJava junk. Specifically, we're using this first or error method, which again takes an observable. We're taking the stream of observables from the database, getting the first item, or throwing something, and then mapping it into something else. It's kind of like you're going from this infinite list and you're just saying, all right, well, just give me the first one. That's all I really care about. And migrating this over into Flow and Coroutines was really nice. We can look at single. That's first or error returns a single. So that leads us. Oh, no, I thought I had more fun question slides. So we can convert that into a flow. That's really easy. This was before I had removed the to-do observable. But what now, though? There's the question. We can just get the first list of items. Since we're in the suspending context, we don't need to do flat map. We don't need to map anything. There's no extra cruft. We just get the first item, and that first item. That first item is just a list of to-dos. It's not. There's no extra asynchronous construct around this. We just get the first item, and the rest is just really easy code. We just check that list. If it's empty, return our pre-canned list. Otherwise, return that list. And that was a nice little tidbit of awkward Rx code that was made much more natural by using coroutines and flow. And that's actually the end of it.
So what's the return policy on reactive programming with Kotlin that you wrote?
Oh, definitely returns. Now still live. Do we have any time for questions?
I was pointing, didn't get the.
Okay, well, that's fine.
Oh, actually, I was going to ask you.
There we go. Thanks.
I was going to ask you, yeah.
One thing I've implemented recently is just a simple broadcaster pattern in my project, and it seems like you're indicating that flows can be used to kind of replace that. And I was actually going to ask you afterwards, your opinion on whether or not that's actually totally.
Yeah. So do you mean when you say broadcaster? Do you mean like an event bus?
Yeah.
Yeah. I think reactive streams can entirely replace event buses because you can just expose a stream, and then the thing that says I'm posting this event is actually just pushing into a stream, and the thing that's annotated with, I'm subscribing to this event is just observing that stream. Event buses kind of just hide the fact that there's a global store somewhere that's pushing stuff into, so you can just do that with RxJava or Flow.
So that's what consumers are doing? Just kind of waits for values to be emitted and then, oh yeah.
Yeah, collect is just waiting for stuff to come through, and